Welcome everyone. Thank you for attending our webcast today. Our topic today seems to be very popular: 3 critical elements to cloud cost optimization success. My name is Chuck Tatham. I am the Chief Marketing Officer here at Densify and speaking to you from the Greater Toronto area. Andy is in our offices. I think one individual in our offices. I actually put on an uncomfortable shirt this morning and ironed the front of it. So I'm good to go. Our topic today and agenda is pretty simple. We're going to try to do all of this in half an hour, so we're going to move quickly. We talk about the state of cloud cost management, something we call the cloud cost pyramid. I will discuss those 3 critical elements. We will do a short demonstration that highlights how we deal with some of these elements. And we will do the always popular Q&A and draw for our Amazon gift card at the end, which you must stay to the end in order to win. So let's get at it. You can enter a question at any point through the console. And as I said, we will endeavor to answer them at the end. If we don't get to all the questions, we will be sure to follow up with each and every one of them that don't get answered. So that's our topic and rather agenda for the day, and let's get at it. So the way we see it, infrastructure cost management over the last number of years with cloud has changed forever. This might seem sort of basic, but for some reason it's a surprise in many cases as organizations get into cloud, that the old way of purchasing servers and provisioning capacity is now radically different. With cloud, you have potentially many individuals and organizations specifying on the fly the resources they desire. And in cloud, that means that new, what we call micro purchases, can be happening constantly. So it's vastly different than what organizations are equipped to control these days or from the past. And there's this expectation on FinOps organizations, finance, procurement organizations, that you're somehow going to control this and optimize it on the fly. And it's extremely difficult. We like to point out that the total cost challenge in cloud is made up of 2 critical elements. One is, yes, making sure you get the right discounts. So reserved instances, committed use, all of that kind of stuff. You got to get the best deal possible. You need to do a good job at this. But we would propose to you that consumption optimization, the actual choosing of the optimal type and quantity of resource for every workload, is where the biggest single opportunity for improvement lies. And there's a bunch of dynamics that feed into that, and I'm going to talk about them. But we commonly see 30 to 40, if not more, % wasted spend in this area. There's a good reason why that is the case. And that is because of a bunch of challenges that we must face in organizations that use cloud. One is that DevOps means that things are happening faster and faster. The agility of cloud drives that. The individuals that are specifying what they want in the cloud, they don't care about cost. They care about speed and performance. It's not their job to worry about cost. So what are they going to do? They're going to err on the side of plentiful. Terraform, CloudFormation, infrastructure as code means that a lot of these purchasing decisions are embedded in code. We call them purchasing as code. And lastly, the app owner, the engineer, generally are resistant to change. Status quo is safe and it's easiest. So it's really impossible to succeed at cost control by getting your purchasing strategies in order and ignoring all of the rest. It's really difficult. The single biggest challenge we find when talking to most organizations is the resistance to change. So people may know there is excess provisioned, but they don't want to change, and they'll think of every possible excuse under the sun to stop that, so, or to avoid making change. So the top 3 elements, really, as we see it, is all about getting past that challenge, those impediments. And what we're going to talk about for the balance here and demonstrate is the elements that allow you to tackle those problems. One is getting codified policy that describes what constitutes waste from a resource perspective for the organization. If everyone can agree on the policy that says, if these conditions exist, we all agree we're being wasteful. And if we all agree, that's the foundation for actually going and getting change made, because there's nowhere to hide. Second is precisely answering, precise answers, excuse my slide, that honor the agreed upon policy and transparency to what is behind those recommended optimizations. That says, if everyone agrees to the policy and you can generate precise answers that adhere to that policy and show the work, show your work, why did we say that there is waste here, then there is trust building. And third is the ability to integrate and have an organized, tracked, and automated approach to applying changes back to the infrastructure. Is there an audit trail? Have we tracked whether those changes are made? If we haven't made the changes, why haven't we? So these are three key elements that we see as being key to getting over those challenges. So if you think about, and this is a simplistic view, FinOps and the ops and engineering side, the app owners, et cetera, teaming around this total cost challenge, it needs to be collaborative, and it needs to begin with the generation and provision of those policy compliant optimization actions. If you do that in a way that is transparent and provides evidence, you will build that trust. That trust ensures that over time, people approve, that changes get executed, that the quantity provisioned is appropriate, and that purchases can be completely optimized, not just by making commitments on the wrong things, but buying the right things and then making those commitments confidently to get the absolute lowest cost base in your cloud infrastructure. So the policy is something Andy will show when he demos the codification of that policy. Now, the precise answer, once you have a policy, you've got to have a precise answer. That precise answer needs to be considered amongst a variety of optimization types. So you've got the instance level. Are we in the right thing? And are we precisely matching workloads? Are we scaling up and down, scale groups, those sorts of things intelligently as it relates to those decisions? And then are we purchasing optimally? And the reality is that you can't solve for one of these things on their own. You can't go and optimize your purchasing if you're buying the wrong instances, for example. So the holy grail is solving for the union of these three elements. Now, Densify is unique in our ability to solve for these things. We don't just go and read the bill and then tell you how much more to commit to. We solve for the union of these things. If we tell you an instance should be changed, it's informed by whether it's already under a reserved instance or savings plan or what have you. We do that uniquely because we have a deep understanding of the application demand patterns. We have a deep understanding of the infrastructure attributes where you might be running. Yes, we ingest that billing data. We have rich tagging abilities, and we have that policy engine, which Andy will show you, that allows us to put all these inputs into the engine and generate these very precise answers. Lastly, you need to be able to get those answers to the people and systems that can make them so, make the changes so. So Densify is not about competing with anything you might already have in your stack. It's about getting our answers or consuming data and getting our answers to the systems that you require in order to communicate with the organization and drive change. So your ITSM process flows, your BI layers, infrastructure as code, Terraform, CloudFormation, et cetera. Perhaps your CI/CD pipeline, your collaboration platforms. If you can get the recommendations into the hands of the people and the systems that control those environments, you have a chance at getting those actions applied. An example, just before we go to demo here, might be a CI/CD pipeline. This is a very simplistic example, but in this case, Densify is learning and analyzing workloads in, let's say, a multi-cloud or individual cloud environment. We're generating our very precise recommendations in both a machine readable form to a Terraform or CloudFormation and a human readable form. The human readable goes to the app owner so that they're informed and they can approve or disapprove. The machine readable is made available through a centralized repository that allows the build process to just constantly, or the patch or deploy process to constantly pick up the recommended specifications for resources. That gets passed to the infrastructure as code piece. There's maybe a round trip to check for approvals. It gets, when it's approved, applied back to the infrastructure. So we're not asking someone to go up to a console and make a change, on an AWS specification. We're just injecting it into the process in an elegant way, such that it can happen automatically. So that's an overview of how we address those three challenges. I'm going to make Andy a presenter, and he will show you some of this. Over to you, Andy.
Thank you. Let's see, we're going over here. And you should be seeing my
Got it.
interface. Perfect. Okay, let's just move that over there. Okay. So just to now dive into those three key areas, we're going to talk about policy, we're going to talk about how our answers get generated, and then the automation of those answers in 10 short minutes. So let's go. The main screen, when you log into Densify, after we've captured the data, and again, we pull in this data agentlessly using APIs into the public cloud providers through Amazon, Azure, Google Cloud, the containers environment through Prometheus. When we get that data, we analyze it. It's typically showing us historical information already. So for example, in Amazon, we'll have 60 days worth of history in which to predict what these, the optimization opportunity looks like. So the data is in here. On the left-hand side, we simply have just a inventory of what exactly it is that we're analyzing. In the middle, it looks like that's our opportunity. So in terms of when we analyze the services that are running, including in Amazon EC2, RDS, and the auto-scaling groups, what does that opportunity look like in terms of sizing? So green is where you want to be, is the optimal size, which is we haven't found an opportunity to optimize. That is typically not the case. When we get a hold of a public cloud environment for a number of our customers, we'll see some significant savings opportunities in terms of right-sizing those instances to better match that application demand with the proper supply. And we'll also typically find some form of risk, which is you may have sized things too small. And so we will look for opportunities to say you might have to spend a little bit of money in order to meet the performance what we predict that application or those instances are going to require. Over time, what we should see is you start taking those recommendations and automating them. That curve should start going up to the right and seeing that green area growing. And then over on the right-hand side is really just a prediction before and after what you're currently using in terms of high-level resources and what that would look like if you took the Densify recommendations. Let's drill down to the second level here into EC2. And this is now showing us the recommendations at the instance level. I won't have time today to dive into the database recommendations as well as the auto-scaling groups, but the auto-scaling groups in particular can drive significant savings in terms of sizing those nodes correctly and also the minimum and maximum number of nodes. We recently looked at one customer's environments where there was tens of thousands of dollars a month where they had sized those nodes incorrectly. So that is a significant potential area of savings. Again, what we'll do here is just now we're analyzing based on EC2 in particular, that service, again, resource allocation and the history over time. Nice thing is customers that have multiple accounts, multiple business units applications, you can use these particular filters to drill down into an area that you desire. And you can also group by any form of different logical or physical grouping. So it might be, tagging business unit and looking at the opportunity based on that, or based on region, or the current instance type, before and after kind of thing. We've got this grouped by application, and we'll drill into the opportunity on one of these in just a moment. The key thing, one of the key pillars, obviously, and we've been talking about that, Chuck has mentioned it, is the optimization policies. So again, these are the guideposts that we would use in order to determine, what is the agreed upon thresholds, the kinds of actions we can perform on different types of business units. You'll see here, we've actually got policies set up for, in general, for this environment, as well as some specific applications here. And when we pick the drop down here, you can see the different areas of policy. If I choose, for example, representative workload and operational patterns, which is, high level, how much data are we consuming in order to inform this answer? So we want to look at 60 days. Some customers might, for some environments, that might be 120 or 120 days or 180 days worth of history. For a test dev environment, maybe it's shorter. 7 days is enough for representative pattern. We want to include weekdays.
Just to interject here,
Sure.
And anyone with a bit of software and some CloudWatch data from AWS can assess whether something is generally busy or not. And that is what the vast majority in the market will do. What you're seeing here is just the ground zero for setting the guideposts for how you're going to make a decision. When Andy goes further to look at the actual workload curves and how we analyze that detail, there is nothing that puts the amount of scrutiny into a decision or a recommendation like we do. So go to that detail, Andy.
Yeah, let's go there. And you can see from a policy perspective, there are settings for things around, what does it mean? When am I going to make a decision to make something larger? When I'm going to, in this case, change an instance family, so maybe it's running on compute optimized, do I want to assess whether or not I want to move to different types of instance families or stay on the same chipset, same storage? Again, those are all the agreed upon guidelines that customers would use. And the nice thing is this is set out of the box, and most customers will change maybe 5 to 10% of these settings in order to make it closer to the way they would operate. So let's drill down into the actual answers themselves. So we'll go back to EC2, and again, I will pick a specific application here. My favorite is the mobile dev environment because it has a variety of different recommendations that you can see. So there's recommendations where we'll see workloads that are essentially flatlined, and we'll say, you should switch those off. They haven't done anything. Essentially, you're using 0% CPU, and the disk network IO is essentially 0. So that's an opportunity to switch something off. Whereas we have other recommendations where something is potentially at risk and we might want to move to a larger instance size in order to make that application better perform. What I'm going to focus in on here is this one that says downsize. So you'll see the details here, which is what is the specific instance? What are we recommending here? So it's a C4 extra large. We're saying that thing should move to a C5 and large Linux. You'll see additional information here. Chuck had mentioned this, which is, do we want to defer that recommendation? Maybe it's covered by a standard RI right now, and you don't want to move it or optimize it, change it to something that puts it out of coverage for a long-term purchase vehicle. So there'll be recommendations for that. And then looking at predicted uptime, what's that current estimated cost versus the savings, and what's the potential savings per month? You've got additional things as well. So effort level, how hard is it going to be to actually automate that recommendation? That's informed by the effort details here, where we'll look at the differences. We know because of the catalog we're assessing into, are we changing hypervisors? Are we changing storage types? Are we moving into a different instance family? Are we, as an example, moving from a published threshold on IOPS or something to something smaller? We just need to surface those differences so that an app owner would know, it's like, is this going to be risky? We put all this stuff on the table so that it's a fully informed answer. And then the additional details as well in current CPUs, what are we moving to, the published benchmark rating for that particular instance one to the next. When we look at those resource metrics, so when we take that data, this is the key to sweet science. We're not just looking at, say, 10 days of data or 30 days of data, and let's look at a peak utilization, let's look at an average utilization. that is typically not enough information for an app owner to say, yeah, I'm comfortable with it. So we basically break down that workload into what we call a quartile. So we've got an 24-hour window based on 5-minute samples, and we break that down into hourly quartiles to say, what is that workload going to do predictably on a typical day? And what's it going to look like when we move to that new instance size? So you can see we're moving to a slightly smaller instance. It's going to get a little busier, but still plenty of white space, as again, based on the published threshold that policy is looking at. So we're looking at the busiest day, memory utilization. A lot of times customers won't have that memory data. We can import that from things like Datadog or Splunk. And again, if we have that data, really soon we'll find additional opportunities for optimization. If we don't get that data, we won't try to downsize something that we say we could put you at risk. And so it's exhaustive in terms of the analysis. And again, you can load the additional data from third-party systems in order to have even more informed metrics. From an approval perspective, and we'll get into that in a moment, but the ITSM integration here is where we can work with systems like ServiceNow or Jira, Sharewell, what have you, or do the approval system through something like a Teams or a Slack. And that, do I want to actually make this recommendation? Is it something that I actually can approve or just approve to a specific instance type? So this is a simplified version of what that approval would look like when we moved over into a different instance. And I think we have a number of different content on our website where we've gone through a detailed automation demo, ITSM integration, and so that would be something to look for as well. Let me wrap up this demonstration because it just am sensitive to time. I want to leave some time for questions as well. In terms of the automation of these recommendations, so if we give you 500 or 1,000 different recommendations, you don't want to become a burden for someone to actually have to go and make a change, and then the infrastructure as code template will put it back to where it was anyhow. So you have to be able to feed into that whole CI/CD ecosystem. Here's that example that Chuck had earlier, which is essentially this is a Terraform template where someone's doing a micro purchase specifying what do they want for whatever reason. Maybe this is the favorite type of instance. Maybe it is, this is what we typically would use for this service and it's extra large just in case.
People would never have just a favorite instance type. That would be crazy.
Exactly. Well, there's hundreds or even thousands to choose from, but the reality is typically they're going to get it wrong, and for the most part they're going to get it wrong by sizing it too large. And so what we do for that, instead of using this as your way of specifying, is essentially a lookup into densify. Say, densify, you tell me what this thing should be. So this is what we call a self-optimization or optimization as code, where it's a lookup into densify saying what should that be. And if we don't have enough data, the policy will determine that and say, well, I'm going to leave it at whatever default you have until I have enough information to make an informed decision. And that will actually ensure, and this is, we're talking to one customer today, says, I like your answers, but I really want to be able to do is actually automate them because that's my problem today. I can't make these recommendations and then just try to keep track, and things are going back to where they were before. So this is what we think is
that comes back to the idea that engineers and technical folks are very busy doing other things. So part of the impediment is overcoming it is to make it easier, and automation allows you to do that. Still control it, but automate it.
Yep, and you can't automate a bad answer. So that's the other thing, is that the answers have to be precise, because if you're automating something and it's now making the application owners uncomfortable, or it's causing application outages because you automated something that was just going to save you $30 a month, but now you put the app at risk.
So a related question from the audience. What do you show someone to get their approval? What are you distributing? Maybe you could show an app owner.
Sure. So there's as an example on that recommendation I was showing earlier, you can see every single recommendation is informed by something called an impact analysis or an app owner report. And it looks like this. So essentially, this is something that could be attached to an ITSM ticket or a Slack message where someone subscribes to an application saying, well, what are you planning to do to my instance? And so all that information I was showing earlier, before and after data, what does it look like on that current instance versus the recommended instance, is all published into this consumable report. that can be, provided in various formats, but typically, this is the detailed report that shows all the before and after statistics and the impact at the end that says, what's the differences in this? What's the impact in terms of cost? And that's the detail that someone will say, okay, now I'm comfortable.
That's the transparency, and it's the, please, as a reasonable human, with all this background, will you approve this change, right? That's
exactly
what this report is about.
Yeah.
Thanks, Andy. Was there anything else you wanted to show, or is that?
Well, I think that's the main component. I think for
couple questions here. Sorry, go ahead.
Yeah, I think in terms of the other component here, that long-term vehicles, we talked a little bit about policy and the answers and things. There's also within the what we call the cloud cost intelligence module of our product, the ability to actually run analysis of the convertible RIs and come up with a better mousetrap in terms of how are you going to leverage and get better utilization, better coverage, and save some significant money on a monthly basis by looking at these convertible RIs. And there's other ones as well where we would look at the savings plans as well. So, I mean, all that analysis and detail is also available. I just don't have time today to dig into, how we come up with all those answers, but it is also part and parcel with the optimization components of the EC2 RDS ASGs for today.
So that knocked down one of the other questions. There's another question on how Densify is priced. Densify does not charge as a percentage of your cloud bill. We don't believe in that. We charge based on the number of workloads or instances, cloud instances that you are managing. So our licensing scales with infrastructure scale, not your bill. It's a bit of a moral hazard to be charging as a percentage. Another question here on whether the slides will be available. Yes, we will make a recording of the presentation available. Another question quickly, does it forecast on the amount we pay per instance, or does it utilize the published rates? Andy?
Does it use, sorry, the amount, I assume that question is around, someone might be having some sort of enterprise discount program or something like that. Yeah, so by default, we'll show the published rate, but we work with customers if they've got specific EDPs, then we simply load in that data in the back end. And so this information would be fully informed by whatever discount they're getting from the public cloud providers.
Right. Great. You assumed correctly. Andy, can you see my screen?
Yes, I can.
All right, it's time for right on the hour. Our drawn winner today, provided he is still on, is a Carlos P. P as in Peter. Congratulations, Carlos. Thanks for attending. And I was going to say don't spend it all in one place, but in that it's an Amazon gift card, you will have to spend it all in one place. But congratulations on that. Anyone else, if there are questions, you'd like some further information from us, questions you were shy to ask in a crowd, answers@densify.com is a great way to do that. We would love to engage with you. And if you'd like a demo or a trial, those sorts of things, all of that's fair game. So enjoy the rest of your day. Here's hoping for some more normal world situations in the coming months. Best of health to everyone, and look forward to talking to you in the future. Thank you all.
Thank you.